OCR Chemistry AS level, breadth in chemistry. This is a 2019 paper, and we are doing section A. So, which statement about the periodic table is not correct? The elements are arranged in groups with similar chemical properties. Yes, we know that is correct. You go down a group and you have groups 1 to 7. The elements are arranged in periods with repeating trends in properties. Yes, we know, because you go across a periodic table, so you go across periods and you go down groups, so we know that's correct. The elements are arranged in order of increasing atomic number. Yes, we know, starting from hydrogen. The element in the halogen group the elements in the halogen group increase in reactivity down the group. Okay. So I'm just going to clear something up here. Is some people, you'll notice, that will do a mistake, and this is quite a common mistake, that there are some groups where when you go down the group you have an increase in reactivity, and some groups when you go down you have a decrease in reactivity. And if it's a non-metal, then when you go down the group you decrease in reactivity, whereas metals, when you go down a group, they increase in reactivity. And that's because once you go down a metal, the group with the metals, metals lose electrons, and so it becomes easier to lose electrons because of shielding, and hence reactivity increases because they're more likely to take part in a reaction because they can easily lose their electrons. However, non-metals, they're acceptors, so they have to accept the electrons. So when you go down a group and you've got more shielding, it's harder to accept the accept electrons into the outer shell because they're so further away. And so for non-metals, you always have a decrease in reactivity down the group, whereas in metals, you have an increase in reactivity down the group. And that means that the answer is D. Which molecule contains the largest bond angle? Okay, so to get bond angles, you need to have learned about shapes. And so let's start with ethene. Ethene, some people might get confused with this because these three are easier, whereas if you look at ethene, you'd have to draw it out like this, and then the red triangles will show you the shape. So actually, it's trigonal planar. As we can see, we have two triangles here, and so the shape is trigonal planar, and you know trigonal planars have 120 degrees bond angles, so we know that's 120. Now H2O, you know H2O has a distinct bent or V-shaped, and that's because it's got two lone pairs, and hence why you have this bend, and so it's 104.5. NH3, we know looks like this, and it's tetrahedral because it's got 3 bonds and 1 lone pair, and so you will have the lone pair up here, and you'll have 107 for bond angles. Now you have CH4, methane, over here. It's also tetrahedral with 4 hydrogen bonds, but it's 109.5. Notice that every time there is a lone pair, you decrease the bond angle by 2.5 degrees. And that's why you also have from 109 going to 107. So the answer is A. What is the percentage composition by mass of nitrogen in NH4, and then you've got 2 and then CO3? Okay, so straightforward, what you're going to have to do is get the MR of all the nitrogens present, and you divide that by the total MR of the compound. So if we calculate the MR of this compound, then we have 96, and MR of nitrogen we know is 14, but we have 2 lots of nitrogen, so we have 28 in total, and so we input it as 28 over 96. Remember, it says percentage, so we times by 100 and we get 29.17, and so the answer is C. Which chemical process is the most sustainable in terms of the atom economy of the organic product? Right. So first things first, organic product, that means it has carbon and hydrogen, oxygen and nitrogen, but it doesn't have to have all of them. So the most simplistic ones have carbon and hydrogen, you can then have also oxygen, and you can also have nitrogen. And so if we skim the products, we can automatically see that yes, this is organic. No, this is not organic because it contains chlorine. whereas C is organic and D is organic. And so automatically we cross out B. So, atom economy. So an easy way to work out atom economy is the MR of the desired product divided by the MR of the total products, and G times by 100. But it's not going to be necessary here because we just want to see which one's the largest, so it makes it most sustainable. And so the MR of CH3OH is 32, and then you divide it by the MR of CH3OH plus H2O, so 50, so we get 0.64. We skip B and we go to C, and we take the MR of CH3, CH2OH, and we divide it by the MR of CH3, CH2OH plus NaBr, so shown over here, and then we get 0.31. We do this again with D, with this compound, so we get the MR of this divided by the MR of the whole thing. We get 0.76. This is the largest MR, and so the answer is D. Right, 5. 8 decimeters cubed of nitrogen oxide is mixed with 6 decimeters cubed of oxygen at room temperature and pressure. The reaction below takes place until one of the reactants is used up. Right. What is the volume of the mixture at room temperature after the reaction has taken place? So you see, if we go back and it says the reaction below takes place until one of the reactants is used up, that's key. So remember that. So let's write it down. So let's see what we've been given. We've been given 8 for the NO and 6 for the O2. That's what they've given us in the question. But how much is actually needed for the reaction? For this bit, we use the molar ratios. So if we take NO, and they've said that we have 8, right? But we have a molar ratio of 2. That means if we take it over to the O, the O2, we only need half, because it's 1 over here and that's 2 over here. So we actually need 4. And if we go to the NO3, and we have 2 over here as a molar ratio, therefore 8 has formed from the reaction. And so we definitely have 8 as the volume of the mixture after the reaction is taking place with the products. So we definitely have an 8 for the product. Now, go back to the O2. We said that 4 was needed for the reaction, whereas they've given us 6. That means we will have 2 left over. So we take the 8 and we take the 2, we add them together and we get 10. So actually the mixture of the products that we have left over will be a total of 10 decimeters cubed. So answer is B. What is the volume of 0.01 moles of N2 at 350 degrees Celsius and 200 kilopascals? Right. So automatically when you see moles and temperature and pressure, we have one equation coming onto our heads, and that's PV equals nRT. So we want volume, and so we rearrange by taking P to the other side and making V the subject. And so we have nRT over P. Right. However, we can't just substitute these values in. We're going to have to change them. And so kilopascals, we need pascals. And so to convert, we times by 1,000. And so we therefore have 200 kilopascals. To go from degrees Celsius, we need to use kelvins for temperature. And kelvins, you just add 273. So you take 350 and you add 273 and you get 623. R is a constant, so it's 8.314. And moles was given as 0.01. You plug that all into the equation and you get 0.000259 meters cubed, because remember, volume is in meters cubed. However, we have either centimeters cubed and decimeters cubed. So if we go from if we go to meters cubed to decimeters, that's timesing by 1,000, we will get 0.2589. That's not an option given here. If we go from meters cubed to centimeters cubed, we times by 1,000,000, and that will give us 258.9. Round up, we get 259 centimeters cubed. Therefore, the answer is B. 0.24 grams of an element X is reacted with 0.01 moles of Cl2 to form chloride with the formula XCl2. What is element X. Okay, so we know elements, we can distinguish elements because of their MR, and we know this equation as moles is mass over MR. So let's see what we have and what we can use to work out. If you write the equation, we have X plus Cl2, and it tells us we have XCl2. So automatically the molar ratio is 1:1, yeah? And so we write down the moles. So for Cl2 we have 0.01, and we have the mass of X 0.24. So we can, because it's a 1:1 ratio, we know that 0.01 of moles for Cl2 is the same for X, it's 0.01 moles. So now that we have the moles and we have the mass, we can calculate the MR by doing mass divided by moles, and then we get the MR of 24. Now, which one of these has an MR of 24? That is B, and so the answer is magnesium. A phosphate V ion, so 5, has the formula of PO4 3-. What is the formula for copper phosphate? Okay, let me just write down the Roman numerals really quickly. It's useful to memorize these. So that's 5 and that's 1. Okay, so what is the formula? Right, so we know this is copper and we know that this is the phosphate. And we know that this is copper's +1, and the phosphate has a +5, and so that's our +5 for the phosphate. We know that oxygen is -2, and we have 4 lots of oxygens, therefore we times it by 8, and we get a total of -8. And it makes sense that this overall charge is -3, because we have -8 and +5, which gives us -3. However, if we look at our final formulas, we don't have a charge. Therefore, we need to cancel out the charge. So if we come over here, we can see that copper is +1, and we can see that phosphate is -3. So in order to make this 0, we need to have the charge of 0, as shown over here. We're going to have 3 lots of coppers, because that will now make overall charge of 0. Yeah? This, we don't change the PO4, because as seen over here, all the charges are correct, and it will still give you negatives, because overall this ion is a negative ion, and we need to make it positive to get to 0, and so therefore we need to be adding coppers to make the formula positive, and so it's copper 3 and PO4. Right, another way you could have worked it out is by switching the charges, and so copper is +1, whereas phosphate is -3, so you do 1 and 3 drag it to the opposite side, and so therefore copper will now take the 3, and the phosphate, you will have 1 lots of phosphate, not this tiny 4, some people might get confused and will change the 4, but no, because remember this is the whole thing, yeah? So this is telling you that you will get 3 lots of coppers and 1 lots of phosphate, which is PO4 3-. So you have 3 lots of PO4 3-. And so the answer is D. Which reaction shows chlorine only being oxidized? Okay, oil rig, so oxidation is loss of electrons and reduction is gain of electrons. So we're looking for an equation that shows that only chlorine is going to be oxidized, and so it's going to be losing electrons. So starting with A, chlorine is an element on its own, therefore it's automatically 0. We have a chlorine over here, but H is +1, therefore chlorine over here is -1. And the chlorine over here, we have hydrogen which is +1 and oxygen is -2, therefore it's -1. You can see it went from 0 to -1 in both of these HCl and HClO, and therefore it's gained electrons, and so it's been reduced. Now you have a chlorine over here, and we have -4 for the oxygen, the total of oxygens, because each one's -2, and you have a +4 for the chlorine. Now, moving on, we go to this compound. We have -4 for the oxygen and a +1 for the sodium, because sodium's in group 1, and therefore chlorine is +3. And over here, chlorine, it will be +5 because of 1 sodium and a total of -6 oxygens. And so therefore we can see that it has gained electrons because it went from +4 to +3, and has also lost electrons because it has gone from +4 to +5. Therefore it's undergone both oxidation and reduction. So that's not the answer. C, we have chlorine over here, it's +5 because we have a -6 for the total of oxygens, and a +1 because potassium is also in group 1. So +5 for the chlorine. Moving on to the next one, we have a -8 for the oxygens, and you have a +1 for the potassiums, and therefore we have +7 for chlorine. And in KCl, you have -1 chlorine because the potassium is +1. Therefore, again, it has lost the electrons to become +7 from +5, and also gained electrons because it went from +5 to -1. So it has been both oxidized and reduced, so that's not the answer. Right, now D, we have chlorine over here as -1 because you have hydrogen as +1, and we have chlorine here as 0 because it's an element on its own. And now you have this one. You might get confused here, but that's okay. Thing is that some will go, okay, so chlorine, that's a total of -2, and manganese, which is +2. Therefore, chlorine's gone from -1 to -2, therefore it's gained electrons. Well, no, because actually, remember, this is 2 lots of chlorine, and the total of chlorine is -2. Therefore, each chlorine is -1. Same thing with the oxygens that we've seen here. So over here we'll say, oh, oxygen is -4. Well, actually, yes, the whole thing of oxygens is -4, but oxygen on its own is -2. And so same thing with chlorine here. That means chlorine started out as -1 and stayed as -1 here, and it started as -1 here and ended up going to 0 because it's an element on its own. Therefore, it has lost the electrons and it has been only oxidized in D, and so the answer is D. Right. A reversible reaction has the enthalpy profile diagram shown below. Which statement about this reaction is correct? Right. The activation energy for of the forward reaction is 120 kilojoules per mole. Right. So activation energy is this. I've marked it in red, and it goes from the reactants to the highest peak. And here it's shown as 150, not 120. So that's incorrect. The activation energy of the reverse reaction is 270 kilojoules per mole. Right. I've done the reverse for using purple. The reverse means we go from the products back to the reactants. That means we're going to have to go from here all the way back to here. So you do 150 plus 120 gives you 270. Therefore, the activation energy, the activation of the reverse reaction is the activation energy of the reverse reaction is 270 kilojoules per mole. Sorry, I got confused between for correct. So that's correct, because you're going from the products back to reactants, so you have to go through this whole jump again, so it's 150 plus 120. The enthalpy change of the forward reaction is -30. Well, okay, the enthalpy change is marked by going from the reactants to the products, and it's this line only. Yeah, you don't count the activation energy, and so therefore you go straight away from the reactants to the products, and that's marked here as 120, not -30. The reverse reaction is exothermic. Well, no, because this shows you the forward reaction, and the forward reaction is exothermic because the products are in lower energy than the reactants. So if the forward reaction is exothermic, the reverse reaction has to be endothermic, not exothermic. The only way this would be correct if you would have this type of enthalpy profile. We have this as the reactants, and that's the products. That would mean that the forward reaction is endothermic, therefore the reverse reaction will be exo. And so because you have the reactants on the products at a lower energy level, so this is an endothermic reaction, the reverse will be an exothermic reaction. And so D is also wrong. And so that's why B is the only correct answer. And so 10 is B. Hydrogen and chlorine react as shown below. So H2 plus Cl2 gives you HCl. Which statement about this reaction is correct? Okay, let's see. Less energy is released on bond making than is taken in during bond breaking. That's the definition of endothermic. Yeah, you have less energy released and more energy is involved in bond breaking than bond making. And however, this reaction over here is exothermic because we have a negative sign. Therefore, this statement is incorrect because we'll have more energy is released on bond making than is taken in during bond breaking. That would be exothermic. B, the enthalpy change for the reverse equation is 184.6 plus. So yes, because exothermic, you have minus 184, the reverse of it will be the exact same thing but with the sign reversed. So this is correct. The enthalpy change of formation of HCl is minus 184.6. Well, it is minus 184.6, but for 2 lots of HCl's, whereas this statement is saying for 1 HCl, and so actually this is only true for 2 moles, and half that number will be true for the formation of HCl. So that's wrong. The temperature decreases during the reaction. No, endothermic, the temperature will decrease during the reaction because heat is taken in, whereas exothermic, heat is released into the atmosphere and therefore the temperature increases. So that's incorrect as well. And so the answer is B. What is the main reason for the increase in reaction rate with increasing temperature? Right, the activation energy decreases. No, that's what a catalyst will do, it decreases activation energy. The activation energy increases. No, activation energy does not increase during a reaction, so that's also incorrect. More molecules have an energy greater than the activation energy. Yes, that's true, because as you increase the temperature, you will increase the energy of the molecules and more than the activation energy, and so the reaction takes place. That's correct. The molecules collide more frequently. Yes, that is true, and it's them colliding in the correct orientation that will cause the reaction to proceed. However, it is not the main reason here. As you can see, they've stated the main reason, and that would be C. So the answer for 12 is C. A catalyst is added to a system in equilibrium. What is the effect on the rates of the forward and reverse reactions? Okay, so when a catalyst is added, it will have the same effect on the forward and the reverse reactions. So that's what we're looking for. There is no effect on the rate in either direction. Yes, there is an effect because a catalyst will speed up the reaction. Without getting reacted. Both rates increase by the same factor. Yes, that's true. The rate in the forward direction increases by a greater factor than the reverse. No. The rate in the reverse direction increases by a greater factor than the forward. No. The catalyst does not favour one direction over the other, it will act the same towards both. And that's why the answer is B. What is the best description for bonding between the carbon atoms in an ethene molecule? Okay, so we have sigma and pi bond, 1 pi bond, 2 sigma bonds, and 2 pi bonds. Right, so an ethene will have double carbon bond, and this is what a double carbon bond looks like. We have a sigma bond between the carbons and a pi bond above the carbon atoms. Therefore, the answer is A. It contains one sigma bond and 1 pi bond. Which compound is unsaturated, alicyclic, and contains an alkyl group? Right. Before we go through the answers, let's just state what each of these are. Unsaturated means we can add more groups, not substitute groups. Okay, when you substitute a group, that doesn't mean that the compound is unsaturated. No, unsaturated means you have the ability to add another group without taking out other groups already present in the compound, meaning that we need double carbon bonds because double carbon bonds will allow you to break that bond and add groups. And so we're looking for a double carbon bond here. Alicyclic just means it's a cycle. It's a circle. And contains an alkyl group. Alkyl group just means carbon and hydrogen groups bond. So carbon hydrogen bonds, those are alkyl groups. So let's go for A. So yes, we have the alicyclic, and we have the alkyl group. However, this is a benzene, and so that the ring that we have here will give stability to the structure because of all the electrons being delocalized, and therefore you cannot actually add any groups here, but you have to substitute hydrogens that are present on here, 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 and here. And so you cannot add groups, only substitute. And so A is not the answer. So yeah, I've written here they're all alicyclic because they're all in a ring. So B, we can see it has the alkyl group. It's a cyclic, but there's no double bonds, and so it's already saturated, and so we cannot add more groups into the ring. So that's incorrect. C, we have alicyclic, and we have an alkyl group, and we have a double bond. So we can break this double bond and add more groups, and so that's why C is the answer. D, some people might think it's D, but that's incorrect. That's because yes, it contains a double bond, and yes, it's cyclic, but if the double bond is not within the ring, then the ring cannot be saturated. And this answer is looking for the double bond to be in the ring because we want to add more groups to the ring, not outside. And even so, would be if we break this bond, we'll just be adding here, and we need to be adding in here, and so it is saturated, and so the answer is C. Which statement about an electrophile is correct? Okay, so an electrophile is the opposite of a nucleophile, and a nucleophile would be like hydroxide. And an electrophile we have Br delta minus. So it is an electron pair acceptor. Yes. So this requires you to know the definition of electrophile. It is an electron pair acceptor, and a neutrophile is an electron pair donor. It is a proton donor. That's the definition for an acid. An acid is a proton donor, and a base is a proton acceptor. It is a negative ion. It's a delta negative, but no, it is not a negative ion because negative ion would look like this, and it would have gained an electron, and here it has not gained an electron. D, it is a species with an unpaired electron. That's the definition of a free radical, not an electrophile, and so that's why the answer is A. This was more about knowing the definitions. A section of a polymer is shown below. Which monomer could form this polymer? Okay, so polymers are formed by this. So this polymer is by addition reaction, and so that means we had to have started out with double bonds. And so the first thing we look for is double bonds. This is through condensation reaction because we have OHs, so that means the removal of water. But once again, we don't have any O's over here, any oxygens, and so we can't have an condensation reaction where we remove a water molecule to join them together because there are no OHs. So there are H's, but there are no oxygens, and so automatically A and B are removed. They also don't contain a double bond, and addition polymerization has to start off with double bonds, so that automatically removes A and B. Right, C and D, which one is it? The easiest thing we do is we can actually draw these monomers, and so if we draw this is what we'd have for C, and now if we join them together, this is what we'd have, and this is representative of that, because if we look at this is, that's a hydrogen, and that's a carbon, and that's hydrogen, and hydrogen, that's carbon and hydrogen here, and carbon and hydrogen here. So we can see that we also have hydrogen here, hydrogen here. We start off with carbon attached to two hydrogens, and then the adjacent carbon will contain a cyanide group, but the next carbon will have hydrogens, and then the next one after that will have cyanide. And so this is the answer. If we look at D and we draw out D, this is what we have. We have two cyanides at the bottom of every carbon and two hydrogens on the top, and a hydrogen on top of the carbon. And so when you join them together, this is what it would look like. We have cyanide on every carbon that's joined. That's not the case here. We have cyanide and hydrogen, cyanide and hydrogen. And so the answer is not D, it is C. Which compound is not likely to have a fragment ion at MZ43 in its mass spectrum? So whenever they say fragments, these are basically fragments that are produced, and this requires somewhat you sitting down, spending an extra few minutes, seeing which fragments came from which compound, and so sort of like a trial and error, where you sit down and work it out. And so if we try it for A, no matter where we break here or here or here, we will not get a fragment at 43. And so that's why A is the answer. And so if we go through them, B, if you break the OH off, and so you count the carbon double bond O and carbon and hydrogen, so we have 2 carbons, an oxygen and 3 hydrogens, we will get 43. And so that will be the peak. If we take compound C, and we split it over here, we can see that this will form a peak at 43 because it's an MR 43, and so that's correct. If we take D and we split the oxygen and hydrogen, the hydroxyl group, this will give us an MR 43, and that's why it's correct. The only one that won't is A, and so that's why A is the answer. Right. Which statement about infrared radiation is not correct? Okay, so this might cause a bit of panic because you might have not come across infrared radiation in chemistry. You might have done other, maybe physics. But they will never give you something that you haven't come across. Yeah, so you can deduce the answer. So if we go through A, the energy from infrared radiation causes some covalent bonds to vibrate more. That's correct. We know that radiation causes vibration of covalent bonds. If you didn't know that, that's fine, because there is one answer that will stick out here because you've learnt it. So we'll come to that. Absorption of infrared radiation by some atmospheric gases is linked by some scientists to global warming. And so we know that global warming is by CO2 and methane, and they are involved with radiation, and so that is correct. Infrared radiation is used to monitor gases causing air pollution. That is also correct. If you didn't know any of these three, when you come to D, it says the action of infrared radiation on CFCs in the upper atmosphere leads to the formation of chlorine radicals. Right. Chances you could have read this whole statement up until here and you would have not understood anything. Then comes chlorine radicals. You've learnt about free radicals. Yeah. However, you learnt that what causes free radicals is UV light, so ultraviolet radiation, not infrared radiation. And so even if you didn't understand the question, you didn't even know any of these answers, A, B, or C, you should know that D, chlorine radicals are formed by UV light. So therefore, it cannot be infrared radiation, and therefore this statement has to be false, and therefore the answer is D. Right, last one. An unknown compound produces the infrared spectrum below. Which compound could have produced the infrared spectrum? Okay, we have 4 of these. First thing is there's always 2 things that should point out to you when you look at a spectrum, and it's these 2. So this peak is an OH peak, and this peak is a C double bond O peak. So as soon as we skim through the answers, we automatically cross out C, because there's only an OH, but we're supposed to have a carbonyl, C double bond O, and we get rid of D because it only has carbonyl when it's supposed to have a hydroxyl as well. Right. The difference here is this is a carboxylic acid, whereas this is an alcohol and it has a carbonyl group. So which one is it? Right. If we go back to here and we remove this, there is something that will distinguish between a OH from a carboxyl acid group, a carboxylic acid group, and an OH on its own. Thing is, if it's from a carboxylic acid, it would look like this. So the peak would slightly go nearer the 3000, whereas the peak for an OH would be closer to the 2500. Yes, but that's a bit harder to distinguish them. What really distinguishes them is this. In a hydroxyl group, you will have this space in this peak, whereas in the carboxylic acid, this peak becomes extremely tiny, just as this alone. And so instead, for a carboxylic acid peak, the OH would look like as if it's a one big whole peak, whereas the peak for a a hydroxyl group on its own will have this dip in here and sort of looks like two different peaks. This means 100% this is from an OH, whereas if we look for, if it looks something like this, then that would mean it's a carboxylic acid. And because we've got that dip in here, that means that this has to be an OH, not from a carboxylic acid. And therefore, that's why the answer is B. And that's it. Thank you very much.